All right, welcome back to math class. This is the help video for the test 2 for rational numbers operations on the study guide. The things that you're going to need to know how to do, you're going to need to know how to convert fractions into percentages, how to convert percentages into fractions, and simplify and reduce, so don't leave any that can be reduced. You'll need to be able to identify equivalent expressions. You need to be able to simplify expressions by distributing and or combining like terms. I want you to review the practice problems from weeks 8 through 12. If you can answer those, then you'll be good to go. Most of you do those for your choice board anyway, but go ahead and look over them again. Those are the type of problems we're going to be having. We're going to be doing word problems that use multiplication, division, addition, subtraction of rational numbers. And remember, rational numbers could be whole numbers. They could be fractions. They could also be decimals, okay? Remember the kinds of decimals, as long as they don't go on and on and on without repeating forever. So as long as they terminate or repeat, then they are a rational number. Review the properties of rational numbers, the ones that are up on the wall and the board, but you guys will all be at home when you take the test, so just review those. It's going to be like a matching format, so you don't have to come up with it out of your head. As long as you can recognize them, you'll be good. So here are some sample problems to practice, and I've been brief on this, but just to kind of remind you, these are the type of problems you're going to see on the test. So for example, the first one here is circle the equivalent expressions, and it could be 1, 2, or 3 different ones that are the same. Like, it doesn't necessarily mean just 2 of them, or there's going to be at least, well, I guess that doesn't make sense to say that there's going to be 1 or 2. There's going to be 2 or 3 that match, okay? So if you found 2, that doesn't mean that, oh, I should stop now. Keep looking, because what if the third one does too? So my strategy that I like to do, I like to just start with the first one and look at that. Well, if I take this first one, which is 2x plus 22, and I go ahead and factor that, I can factor out a 2 and get x plus 11. So I know that this first one is the same thing as 2 times the expression x plus 11. Well, here we go, right here. There's a match. And I'm looking at that third one to see, well, could that one also be? But no, it couldn't, because there, the 2 and the x are multiplied to each other, but that 11, the 2 is not distributed to that. So this is the only 2 that match are right here. Now, the next one, I've got a -4. So if I go ahead and distribute that to both of those, -4 times a positive 2x gives me -8x. -4 times a positive 4 gives me a -16. So I have to see if there's one that looks just like that. There is. So I know that these 2 are a match, and that this one cannot be. This one cannot be because it's got a plus in the middle, and that changes it. So now simplify by distributing. Well, we've already done that. Let's practice it again. I'm going to take that number out front, the positive 11, and I'm going to multiply it to both things inside. So positive 11 times 3 is 33x. And positive 11 times -2 is -22. Okay, so far so good. So you need to be able to do it when there's a positive out front, but what if there's a negative out front? Well, you do the same thing, but you just make sure that that negative sticks with it. So -2 times 2x is -4x. -2 times 10 is -20. There you go. Well, what if it is a decimal? If it's a decimal, it doesn't matter. You do the same thing. So let's look at that. If I have 5.1 times 1.1, I can go through and do that math fairly quickly. And I know that I've got a decimal place here and a decimal place here, so I'm going to have to move in 1, 2 right here. So I know that the first term, which is 1.1 times 5.1x, is going to be 5.61x. Okay, now I've got to distribute that 1.1 over to the 2.2. So let's do it here. 2.2 times 1.1. Well, that's a 2, 2, and a 2, and a 2. And again, I've got those. I got a tenths place here and a tenths place here. So I'm going to have to move it over 2 spots. So that leaves me with a positive 2.42. So the process is exactly the same. I just have to make sure that I'm paying attention to my decimals. And if I do it with decimals, I can also do it with fractions. So let's take that 3 halves, positive 3 halves times both of those things. Let's see, I'm going to clear some area to do a little bit of work right there. Let's clear this area and do some work. So actually I could probably move it over this way. Let's do that. All right, so I've got 3 halves times 8 times 8r. Well, I can just put that here. I could go ahead and reduce it, or I could just do 24 over 2 and recognize that that means 12. Okay, so my first term is 12r. And now I have a positive times a positive. I know I'm going to have a positive there. And let's take my 3 halves times 10. Straight across. That gives me 15. So see, it doesn't matter that there is, that it's a fraction, because it all just does the same thing. All right, now how is this different? This is, we are going to distribute and combine like terms. So let's look at this, and I want to remind you that you're going to take whatever term it is and the sign in front of it, and that's what you're going to distribute to each thing. Okay, so let's see, is there anything else? I don't see anything in front of the second set of parentheses except for a plus. So I can just assume that there's a 1 there, or I can just think that it's a plus. But if I've got a 1, that really doesn't change anything. It just helps us to get rid of the parenthesis. So the first term, I still have that 6w out front. Nothing has happened to it. But then I've got my positive 3 times a positive 2w. Well, that gives me 6w's. And then I've got a positive 3 times a negative 2. Well, that gives me a negative 6. And then, like I said, I've got this assumed 1 in front of it. So I can just say, well, anything times 1 is itself. So I'm just going to go ahead and put 7w plus 3, and I still have plus 5. Okay, now I need to gather up my terms that are like. Well, I have a 6w, I have a positive 6w here. This one's assumed to be positive because there's no negative in front of it. I have a positive 7w there. So 6 plus 6 plus 7, that's 12 plus 7, that is 19 W's. And then let's see, I have, my constants are, I have a negative 6, a positive 3, and a positive 5. So 3 and 5 is 8. Negative 6 plus 8 means negative 6 plus 8 is a positive 2. So my answer there is 19w plus 2. Good. All right, now let's see. Let's practice one more time. This may or may not be different. Let's see. So first I'm going to see, where am I going to have to distribute? Well, I've got this negative 8 here, and I'm going to have to distribute that to both of these terms. I've got this negative 10 here. I'm going to have to distribute that to both of the terms. And then here, I don't see a number in front of it, so I can assume that's a 1. That's a negative 1, right? Or that you're just going to be distributing the negative, which would change all the signs on the inside there. Boop, boop. So let's start working through this. So I still have the 8f out front. That hasn't gone away. But now I have negative 8 times positive 4. Negative 32. I have negative 8 times negative 2f. Well, that becomes a positive 16f. Now I can move on. Negative 10 times a positive 7f. Negative and positive makes a negative 10 times 7. I've still got the f. Negative 10 times negative 10. Well, that becomes a positive. Now, negative 1, So think about it, you know, you can look at it that you're distributing the negative, or if it makes it easier for you to recognize that there's a number there, you can say distributing -1. So that's -1 times 8, -1 times -8f. So now I have done all of the distributing, and what I can turn my eyes toward combining like terms. So I have an 8f there, it's assumed positive because there's no negative in front of it. I have a positive 16f, a negative 70f, a positive 8f. So let's see, when I put all those together, 8 and 16 is 32. So I've got 32 positive f's and negative 70f. Same sign, different sign. Well, they're different signs, so I'm going to subtract. I've got 70 minus 32. 38. Keep the sign of the larger number. So the larger number is negative. So I know that I have negative 38 F's. Okay, and now let me look at my constants. I have a negative 32, a positive 100, and a negative 8. So negative 32 and negative 8 is negative 40. And I have a positive 100. The difference in those is 60, and it's more positive. So my actual answer for that is negative 38f plus 60. All right, so far so good. Everything making sense? Okay, so then let's move on. Sorry about that noise. I have emails coming in. All right, Mrs. Bell baked cookies for her family. Her boys ate, let's see, the boys, they ate 3/8. And the girls ate 1/8. How many more cookies did the boys eat than the girls? And it says to write it as a simplified fraction. Well, it's kind of weird to ask that as a fraction, but I guess if we're looking at all of them as a whole, like maybe this question would make more sense if it were a cake or a pie. But right now we're just going to say that out of the 8 cookies. So we know that when we're comparing how many more, we're finding the difference. And to find the difference, we need to have a common denominator, which we have. So we keep that common denominator. 3 minus 1 is 2. If we reduce that by 2s, we've got 1/4. So the boys ate 1/4 more cookies than the girls. Or 2 out of 8 cookies more. All right, at Henry's Hoods. And let me take a quick minute to kind of talk about this. Because we had originally planned that we would all be in school for the test, you would have the option of doing a paper copy of the test. But since we're all going to have to take the test, you all are going to have to take the test on Canvas, you will not have an opportunity to submit a paper copy. You can use scratch paper. Please don't use a calculator. But you will not really have to do any labeling other than what it tells you to do. Like here, it told you to answer in a simplified fraction. All right, at Henry's Hoods, 15 out of 75 sweatshirts had no hoods. What percentage of sweatshirts have no hoods? So this one's easy. It's pretty straightforward. We know 15 out of 75 have no hoods. And we're going to answer using the percent symbol. Well, we know how to find a percent. Here, you could find an equivalent fraction that has 100 on the bottom. I think it's just easier most of the time to use long division. So 15 divided by 75. 75 does not go into 15, so I'm going to expand it with some zeros. The decimal I put up there. Let's see, I think that 75 goes into 152 times. No remainder, so I've got 0.2. And if I'm going to write that as a percent, I need to move the decimal 2 places and add that symbol. So my answer here would be 20%. All right. At Birdie's Board Games Galore, 2/5. These are kind of hard for me to see, so I'm going to say 2/5. The struggle is real here. Okay. So let's see, 2/5 of the games are card games. And among the card games, 1/3 have wizards. If no other type of card game has wizards, what fraction of games at Birdie's Board Games Galore have wizards? So I need to know what 1/3 of 2/5 is. Well, we know that of indicates multiplication, and I can do that straight across. So 2 times 1 is 2, 5 times 3 is 15. We can safely say that 2 out of every 15 games has wizards. All right, this morning Rob took a social studies test. He got 45 problems right and 15 problems wrong. What percentage did he get correct? So to find that percentage, I'm going to need to know the number of right, so the number of ones he got right, over the total. So let's find out what that total is. Well, if I add the right ones and the wrong ones together, it gives me the total of 60. So I know I've got 45 out of 60 correct. And we can find out what that is using our long division again. Well, 45 is too small. 60 doesn't go directly into 45, so I'm going to expand it, putting some decimals in there. Let's start with one decimal. See, 45 turns into 450. 60 goes in there 7 times. That gives me 420. Well, I have a remainder, so I'm going to need to add another 0. 300, whoa, good. 60 goes into 300 exactly 5 times. There's no remainder, so I've got 0.75, and it tells us to write this as a percent. So I'm going to move the decimal 2 places and write the symbol. So the answer is 75% is Rob's grade on that test. All right. The last one on this page. Of 50,000 runners in a marathon, 5,000 were under the age of 18. What percent of runners were under the age of 18? So 5,000 runners, I'm going to write that without any commas just because it's easier for me. 5,000 out of 50,000. So we need to find out what the percent is. And we've seen from what we're doing earlier that we can just do long division. That's probably the easiest way. Or you can do this, let's see, some of us like to do long division like I do, long division. And some of us like to find equivalent fractions. So I'll do it both ways. Okay, let's look at it both ways. So if I'm looking at long division, I've got 5,000 divided by 50,000. Well, 5,000 is not big enough, so I'm going to put a decimal. That'll add a 0. So now how many times does 50,000 go into 50,000? Exactly 1 time. So I've got 0.1. If I write that as a percent, I'm pretty confident in saying that that's 10%, but let's see how we would have done it if we would have found an equivalent fraction. Well, if we'd have found an equivalent fraction, I'd have my 5,000 over my 50,000. And my goal would be to get it over 100, because that's what tells me what a percent is. Well, I know that I could, divide by 10, divide by another 10, or just right in the beginning, divide by 100, and that takes it down to 50 over 500. And then if I divide by 5 on the top and the bottom, 50 divided by 5 is 10, 500 divided by 5 is 100, which gives me 10 over 100, which is indeed the same thing as 10%. So either way I did it, 10%. So I can feel pretty confident. I got the same answer both ways. Almost done. On Saturday night, Jen and her friends ate cake for dessert and had 3 slices of 10 left over. Okay, so they've got 3/10 of the cake left over. The next day, she ate 1/3 of what was left. So she ate 1/3 of those 3/10. How much cake did she eat on Sunday, right? Your answer is a reduced fraction. So I'm trying to find out what's 1/3 of 3/10. Okay, well, it's easy peasy. We can multiply straight across. 3 times 1 is 3. 10 times 3 is 30. I recognize that that fraction bar is the same as saying 3 divided by 30. which is 1/10. Which kind of makes sense if you think about it. There's 3 out of 10 pieces and she eats 1/3 of those. Well, it's already kind of broken up into 3s. Like if I look at it, we see that she had 1/10 of it. And that kind of makes sense. If I have a cake, let's see, how would I even go about? Each side needs to be in 5s, right? 1, 2, 3. 1, 2, 3, 4, 5. Gosh. How many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's too many. See, I'm not very good at this. Let's say, okay, for the sake of Mrs. Witt being challenged when it comes to drawing things evenly, let's just say that this is a rectangular cake. There we go. And there's 1, 2, 3, 4, 5. Okay, so there's 10 pieces of cake here, right? And the first night they ate all but 3 pieces left. Okay, so they ate this many and this many. So that's how many is left, is 3/10, right? And then she's going to eat 1/3 on that last day. Well, it's kind of already divided into thirds right here. There's 1, 2, 3 pieces. And if she eats 1 of those, then she's eating 1 of the 10 original pieces, 1/10. Okay, that was kind of a side story. Sorry for that. It just kind of struck me. Okay, Michael owns a juice stand in the mall. On Monday, he used 1 2/3 bags of oranges. On Tuesday, he used 1/5 as many than he did on Monday. How many bags did he use on Tuesday? Write your answer as a reduced fraction. So what I'm trying to find is, what is 1/5 of 1 2/3? And to do that, I'm going to go ahead and take my 1 2/3 and make it into an improper fraction. So 3 times 1 is 3, plus those other 2 makes it 5/3. So what I really want to know is, I have 5/3. What is 1/5 of that? And again, you can automatically see those 5s can kind of reduce, or you can go ahead, if you don't notice that, and just multiply straight across the top, straight across the bottom, and then reduce that. 1/3. So how many bags of oranges did he use on Tuesday? He used 1/3 of a bag. Sven, it says 5/6. Okay, Sven bought 5/6 of a pound of green apples and 1/2 of a pound of red apples. How much more did the green apples weigh than the red apples? Okay, so again, how much more? That means we're looking for a difference in something. So I'm going to need 5/6. What's the difference with the 1/2? Okay, easy peasy. However, I'm noticing that they do not have common denominators. So I'm going to turn that 2 into a 6. I'm going to turn that 2 into a 6. What I'm going to multiply it by the whole fraction of 3/3, because that's the same thing as multiplying by 1, and we know that we can do that. So let's see, I've got my 5/6, and from that, when I scale this up by 3, I have 3/6. So when I'm subtracting fractions, I keep the same denominator. 5 minus 3 equals 2. 2/6 reduces to 1/3. So the question was, how much more did the green apples weigh than the red apples? Well, 1/3 of a pound. All right, Mrs. Witt's neighborhood voted to install a new welcome sign on the corner. Out of 35 voters, 28 were in favor of the new welcome sign. What percentage of the votes were in favor of putting the new welcome sign? Write your answer using the percent symbol. So 28 in favor out of a total 35. Okay, well, that's easy peasy. 28 out of 35. I'm going to use my long division because that's my go-to. You know, I prefer long division. If you feel like it would be easier for you to try and figure out what you could scale it to make that 100 on the bottom, go ahead and do that, but I don't like to do that, so I'm not going to. Let's see. Decimal because 28 is not big enough. So how many times is 35 going to 28? I'm going to say 8 times, and that indeed is exactly right. So I have 0.8 and I'm going to write my answer as a decimal. I'm sorry, not as a decimal, as a percent. Good catch, you guys. So 80% of Mrs. Witt's neighborhood wanted to put in the welcome sign. Now, I'm going to go ahead and tell you that this looks very similar to how you're going to see these properties written on the test. So just kind of keep in mind that I'm very specific about whether it's the property of addition or multiplication. So don't just get hasty and say, oh, that looks like associative property and put it there. Make sure that you've got the right one matched up. So associative property of addition tells us that we can change the association or change the way it's grouped when you're adding. So I'm going to find the one that looks like that. Here it shows me that I can change this grouping when I'm adding, okay? And then for multiplication, it's going to look very similar to that, only we're going to be multiplying. Oops, not the color I want. Going to be multiplying. So these two mean that you can change the groupings. Okay. And then these two are both the commutative. And commutative, remember, is that guy, Josh, that he gets on the subway and he goes from one class to another. He goes from one to his internship and back. So it means that you can change the order. So the one that changes the order using addition and the one that changes the order using multiplication. And then the identity property, well, that just means it stays the same. It maintains its identity. It stays the same. So what shows that you can add something and keep it the same way? That is a plus 0 is still a. And for multiplication, it is that a times 1 is still a. And then finally, the distributive property tells us that we can multiply across the parentheses, right? And that looks just like a. So make sure that you can recognize these and select the example or the definition with the name of the property. And with that, I believe you are ready for the test. It will be on Monday or Tuesday of next week. Just go ahead and log into the module. The access code is on the direction page. You may use scratch paper, notebook paper, whatever, but please do not use a calculator, not on this one. Other than that, good luck. You guys are rock stars. See you soon.